Hi all, we are starting now chapter 11. Unfortunately, I'm still quite sick, so my voice is going to be very funny in these next few videos, but hopefully you can put up with that. So, chapter 11 is all about anti-differentiation. We're going to start with exercise 11a, which is working out the area under the graph, and then later on we're going to come back to the area under the graph using some differentiation techniques, which we'll also learn from exercises 11b to 11d. So just as an introduction today, we are going to be learning about finding the area of the graph by using geometry. What you need to be able to do is find the area of the sections of a graph using the area formula. So for example, if I were to ask you to find the area between the line and the positive x-axis, we can easily do that because we can see that a shape is created here. We've got a triangle. But that's not quite easy when I want to ask you to find the area underneath this part of the graph. I mean, it kind of looks like a trapezium, but also not really because it is curved at the top. So there has to be some sort of other technique to be able to find the area that is bound between the line and between two x values of 1 and 2. So what we can do is we can approximate it. That's as best as we can get right now. I can create a rectangle. So that's probably the easiest shape at this stage. That is at the y value when x is equal to 1. So this is what we call a left point estimate, because what's happening is I'm drawing up my x value and that becomes the left part of my rectangle. So you can see that the height of this rectangle is going to be the y value at 1. So this is what we call a left point end estimate, and you can see that this is, in this specific case, it's an overestimate because I've got more of the triangle than I do the graph. I also can do a right endpoint estimate. So the same idea, I've got my graph, and this time I'm going to go up from an x value, and that will form the right side of my rectangle. So you can see now how this rectangle here is still an estimate, but it's going to be an underestimate because there is this little section here. And this is what we call a right endpoint estimate. So in general, what we can do to be able to find an approximate area under the graph is to draw lots of little rectangles and be able to add these areas up. Generally, when we have a left end approximation, what we do is the x value, whatever the x value is, that becomes the left-hand side of my rectangle. And all we do is we continue drawing all of these little rectangles in this case, until we're able to find the area of each of them and then add them all up. The right endpoint, as you can see, my x value becomes the right-hand side of that rectangle, and same idea. It's not always an over or underestimate. That very much depends on the actual shape of the graph. Now, just as a quick way to be able to do this, we can use these formulas. So b minus a is simply the last x value minus the first x value. So in this case, it would be 5 minus 2. And then divided by n. N is the number of steps that I have in between them, or in this case, number of rectangles. So in this case, I have 6 rectangles. Now, what does that do here? That actually gives me the width of my rectangle here. So if you think about it, that's 5 minus 2 is 3, divided by 6 is a half. So we can see that each rectangle is 1/2. Now, that is the width of the rectangle. What is the height going to be? It's going to simply be the y value at that x value there. So when x is equal to 2, that will be the height of this rectangle. When x is equal to 2.5, that will be the height of this rectangle. And so that's exactly what is described in this formula here. So f of x0 plus f of x1 and so on. So that's the y value at the first x value, the y value at the second x value, and so on. You can use this formula, and you can also just find the area of each of these rectangles separately and then add them together. So whatever you find easiest works well. One other thing just to keep in mind, if you want to be able to find a better approximation, what you can actually do is take an average of the overestimate and the underestimate, and that gives you a pretty good approximation between the two. So example 1, approximate the area of the shaded region using subintervals shown to calculate. So we can see that they've separated these all out by an interval of 1, and they want us to do it in the first part using a left point end estimate. So that means when I'm drawing my rectangles, I'm going to be using the left-hand side as the part of the rectangle to form that rectangle. So here, this is the left-hand side that forms my rectangle there. I can go all the way down. That forms my rectangle there, and that forms my rectangle there. So I can now see I've got 4 areas. So that's area 1, 2, 3, 4. And all I have to do is find the areas of each of these and then add them up. So what we can do is exactly that. They've given me the height already, which is very good that they've done that. Sometimes they don't do it, and so you need to substitute the x values into the function to be able to do that yourself. So for example, for area 1, what I have is I have a width of 1 and the height is going to be 5. So the area of that triangle, the rectangle there is 5. Area 2 has a width of 1 again and a height of 3.5. Area 3 is going to have a width of 1 and a height of 2.5. And then area 4 is going to have a width of 1 and a height of 2.2. So I'll just work that all out there. And when you add them all up together, you are going to get, if you can pull out your calculator and work it out on the spot, that becomes 13.2 units. So that's using the left point end estimate. How does it look with the right end point estimate? Is the same thing, but this time the right hand side forms the rectangle. So in this case, if I want to form a rectangle, it'll be based off this x value there. So that's the right hand side. Again, this is on the right hand side there, that forms that rectangle. Right hand side forms that rectangle. Right hand side forms that rectangle. So we can see I've got 4 areas, and again, I can complete what I had before. Now, instead of doing it this particular way, which is finding the areas separately, I'm going to do it using this particular formula here. So b minus a on n, and then the height of each of them, add them all together. So b minus a, 5 minus 1, divided by how many intervals do I have, or rectangles? So I've got 1, 2, 3, 4 in this case. So you can see that that's 4 divided by 4. That just simply gives me the width. So it's going to be 1 times, and now I just need to multiply by the height. And this is why I like to draw my lines with that circle, because I know that that's the height there. So the height of the first rectangle is 3.5. The height of the second is 2.5. The height of the third is 2.2. And the height of the fourth is 2. When you add that all up together, you get 10.2 units squared. Sorry, I should have written squared on this one as well. Now, you can see that this is less than the previous one because this is an underestimate. I've got all of this extra area here that I have not accounted for. Whereas in this question, I've got this extra area here, which I have added, and that's why that number is a lot larger than this one. But for the most part, they're both good estimates for us to use. And that's the end of exercise 11A.